is a proof? In this session, you're going to be introduced to proofs in geometry. And I wanted to give you an overview of what a proof is. So let's take, for example, if you need to solve a crime mystery. So if you have some kind of crime that you want to solve, you would first survey the crime scene, you would gather facts, you would write them down, and then to solve the crime, you would take the known facts and step by step, you would show who committed the crime. So to show who committed the crime, you would take the facts that you wrote down at the crime scene, and you would take all those facts and use those facts to step by step solve and show who committed the crime. So you would conscientiously be providing evidence for each statement that you would make. And that's really what a proof is in geometry, is that all you're doing is for each statement that you make, you are providing the backup or the evidence for each statement you make. So, again, proofs, that's the same process that you're going to use as I just explained for how you might solve a crime, where you take step by each piece of evidence to help you solve the crime. And the same is true for proofs. So here are the steps that you're going to use when you create a proof. So first, you're going to create the statement of the theorem. You're going to get or create the statement. And you're going to state what that given is. And then you get or create a drawing that helps represent the given, and you state where you're going to prove, and then you provide the proof itself. So this is going to make more sense, so keep with me. So think of proofs like a game. And the object of the proof game is to have all the statements in your chain linked so that one fact leads to another until you reach and prove the statement, until you reach the proven statement. So once you lay down your strategy, you can proceed statement by statement, carefully documenting your every move in successfully numbered steps. And if you look below, here's an example of a proof. So I know so far I've just been explaining what a proof does. So here's an actual example. And you can see that on the left of the proof down below, on the left column, all the things in the left column are made on the left. So statements are made on the left, and they're numbered. And they correspond to similarly numbered reasons on the right. So all the statements that you make must refer back to your figure or whatever the first statement that you start with. And then the last line should be exactly what you wanted to prove. So here, let's take a look. The first statement is that we've got this algebraic equation, and that's our given. This is what we're trying to solve. It's our given problem. So remember, our statements will be on the left, and the reasons we're able to make those statements will be on the right. So in solving this equation, we know the first thing that we have to do is multiply each side by 2. And that's our next statement. The next step in solving this problem, after we multiply each side by 2, would be that we would have 3x plus 5 equals 14. The way that the reason that we're able to go from statement 1 to statement 2 is by using that multiplication property of equality. So we were able to simplify this equation a little bit by multiplying each side by 2. We got rid of that 2 in the denominator, and we did that by using the multiplicative property of equality. Then our next step to solving for x is that we would want to subtract 5 from both sides, which leads us to this next statement, that 3x would equal 9 after we subtract 5 from both sides. And the reason we're able to make that statement is by using the, that should be the subtraction. That's an error there. That should be the subtractive property of inequality. And then last but not least, we finally are able to solve for x. This is what we were trying to prove, is we were trying to find out what x equals. We were able to figure that out by dividing 3 on each side. And the reason we could say that x equals 3 was we used the division property of equality. So that's an example of a proof. So we go step by step. We're showing our progress from what we're trying to, our original statement, and what we're trying to prove, to the actual solution. Our statements are on the left, our reasons are on the right. So there's a lot of properties we can use with proofs. These are what you learned last year in algebra. I'm not going to go over a lot of these. So really, if you've ever solved an equation in algebra, which you've already done, you've all already done a proof. You've already done it. What you have not done is given reasons for all your steps for solving equations. We know we can use, sometimes we have to add a number to both sides to solve an equation. Sometimes we have to subtract. Sometimes we multiply. Sometimes we divide. The reflexive property of equality is just saying that the same thing is equal to something else. Symmetric is if you say if A equals B, then B would have to equal B to equal to A. We've got the transitive property. If A equals B and B equals C, then we should be able to say that A equals C as well. And then the substitution property is when you can substitute in a value into an equation. So you're gonna, these are properties that we can use for our reasons when we're going to put into the right side of our proof, the right column. So let's see here. Here's another example of a proof. So here we are given this information here, this line, and then the points on the line. This is our given. And we want to prove that segment PQ, which is this segment here, segment PQ is equal to segment PS. So if we were to take segment PS and subtract from it segment QS. So which one is QS? From here to here. So if we were to take the segment that QS and subtract from it QS, PS, and subtract QS, we would get the length of QP. So we want to prove this. We want to prove this. So you always start with your given. You always start with your given. So here the first statement is that we've got points Q, P, R, and S, and they're collinear. They're all in the same line. That's a given. That was in that figure. Then next, we can state that we know that the length of PS is equal to QP plus QS. And we can make that statement given the segment addition postulate that we worked with already. Next, we can start to solve for QP or PQ, because that's what we're trying to solve, is that QP equals this. So in starting to solve for QP, we want to get QP all alone, so we would subtract QS from both sides using the subtraction property of equality. And then we can state that QP or PQ equals PS minus, that should be a minus sign in there. And we can do that by using the symmetric property of equality. So that's what you're going to be working with this week, is solving or setting up proofs and giving reasons.